Welcome to homogeneous linear first order equations. So recall homogeneous linear first order take the form y prime plus p of x times y is equal to 0. So we're going to start off with the most basic homogeneous linear first order equations. So let's just consider p of x to be a constant function. So we'll take y prime is equal to, y prime plus a y equals 0, where a is a constant. Then we can rearrange this equation. So we are going to rearrange. So this will become y prime is equal to negative ay. And then if we divide through by y on both sides, we get y prime over y is equal to negative a. This left-hand side, y prime over y, we essentially have a perfect u substitution set up. If we integrate that left-hand side, that is just the natural log of absolute value of y. So from here, we're going to go ahead and integrate. So we're looking at the integral of y prime over y dx. And this should be equal to the integral of negative a dx. On the left-hand side, this is the natural log of the absolute value of y. The right-hand side, this is just negative a times x. And then we'd have a plus c. If we then do e to the on both sides, this winds up giving us that y is equal to essentially plus or minus e to the negative ax plus c. And then that plus c, we can rewrite that as e to the negative ax times e to the c. And then that's just a constant. So we'll rewrite this as y equals capital C, e to the negative ax. And here our capital C is either plus or minus, depending on what we're working with, e to the lowercase c. So these basic linear differential homogeneous equations, we wind up getting that y is just equal to c e to the negative ax. So if we wish to generalize this, let's go ahead and take a look at y prime plus p of xy equaling 0. We're going to play the same game here. So we have y prime is equal to negative p of x times y, or y prime over y is equal to negative p of x. Once again, we're going to integrate both sides. And we wind up looking at the integral of y prime over y dx is equal to the integral of negative p of x dx. So we get the natural log of absolute value of y is equal to negative integral of p of x dx. I'm going to just tag on the plus, I'm going to just tag on the plus c here. this becomes y is equal to, we have our capital C e to the negative integral p of x dx. So it's up to you. I tend to just rework through this every time I solve the problems, but you are also welcome to jump straight from the y prime plus p of x y equals 0 to this final solution. So let's go ahead and just do a quick problem. Let's find the general solution to y prime minus 3x squared y equals 0. So in this case, again, rearranging, we have y prime is equal to 3x squared y, or y prime over y is equal to 3x squared. And if we integrate both sides, we are looking at the integral of y prime over y dx is equal to the integral of 3x squared dx. This again is the natural log of the absolute value of y is equal to the integral of 3x squared dx as just x cubed plus c. So this becomes y is equal to, we have a capital C e to the x cubed. Again, that is precisely y equals c e to the negative integral of negative 3x squared, as we found in our formula we should get. Let's go ahead and solve the initial value problem. Y prime plus cosine of 2xy equals 0, with y of 0 equals 5. This time around, I'm going to go ahead and just jump straight to the formula. So our p of x here is cosine of 2x. So we are looking at y is equal to capital C e to the negative integral of p of x dx, or y is equal to capital C e to the negative integral of cosine of 2x dx. Well, the integral of cosine of 2x is 1/2 sine of 2x. So we are looking at c e to the negative 1/2 sine of 2x. The plus c is already in the formula, so we don't need to write our plus c. So this is our general solution. We can then plug in our initial condition of y of 0 equals 5. So from here, y of 0 is equal to 5 is equal to c e to the negative 1/2 sine of 2 times 0. Sine of 0 is 0. So this is e to c times e to the 0th. We have 5 is equal to c e to the 0th, otherwise known as 5 is equal to c. So our particular solution, we get y is equal to 5 e to the negative 1/2 times sine of 2x. So this is just solving basic homogeneous linear differential equations. Just a quick warning. Be sure to rearrange your equation into standard linear format before applying this formula. So be sure to rearrange your equation, your differential equation, into standard linear form before applying the shortcut. So for example, if we had x times y prime minus y equaling 0, you would want to divide through by x. So this is equivalent to y prime minus 1 over x times y equaling 0. So our p of x would be negative 1 over x, not the negative 1 that would first appear. So just something to watch out for in these problems. Be sure to rearrange to standard linear form first.